we are given the graphs, not the equations. So we're going from a graph. Okay, we want to state the discontinuity and type and give the behavior around the discontinuity. Okay, so remember the types of discontinuities are infinite and removable. And that means infinite, that's at a vertical asymptote, and removable, that means it's at a hole, right? Okay, so I'm just going to go left to right on my graph. What's the first break in the domain? This vertical asymptote, right? Okay, so this vertical asymptote, that is an infinite discontinuity, correct? Okay, so it is a vertical asymptote at x equals -3. Now they want us to give the behavior around that asymptote. So I need to fill in the limit as x approaches, and it's -3 from the left. And then this one is -3 from the right. Are y'all good with that? All right, so what is the limit as we approach -3 from the left? Infinity, positive infinity. Okay, what about as we approach it from the right? Negative infinity. Good. Okay, now, is there another break in this domain? Is there a second discontinuity in this graph? Yeah, right here. There's the hole. Okay, so that is discontinuity number 2. It is a removable discontinuity. It is a hole at, and that is at 2, -1, it looks like. And now we want the limit as we approach that. So first I'm going to fill in as we approach 2 from the left and as we approach 2 from the right. All right, so as I approach this hole from the left, so as x gets closer and closer and closer to 2, what's y getting closer and closer and closer to? What is the y value approaching as I get closer to this hole? It's not infinity or negative infinity. As we approach that, it's approaching a specific y value. It's -1. It's the y value of the hole. So it's approaching -1. And from the left, it's doing the same thing. So if it's a hole that you're approaching the y value of the hole. When it's an asymptote you're approaching, you're going up or down forever. Does that make sense? All right, so what about in this next one? What types of discontinuities do you see? 2 vertical asymptotes. So both discontinuities here are vertical asymptotes, so infinite. Right, but that's not a discontinuity. Discontinuities are just the vertical asymptotes and the holes, the breaks in the domain. The horizontal asymptote guides the end behavior, but it doesn't affect the domain. All right, so vertical asymptote, I'll go left to right. So this first one is at -2. So I'm going to fill in here as x approaches -2 from the left and as x approaches -2 from the right. All right, so as we approach that from the left, look at the graph here. What's it doing? Going to negative infinity. And as we approach it from the right, to positive infinity. Good. All right, the second vertical asymptote is at +2. So that again is infinite. It's a vertical asymptote at x equals +2. So again, that'll be as x approaches 2 from the left and 2 from the right. And let's see, as it approaches from the left, what's happening? Negative infinity, and from the right, positive infinity. Feel okay about identifying discontinuities in a graph? Limit notation around a discontinuity? From the left, from the right? Bless you.
Yeah.
All right. So now this, you are not going to have to sketch anything on the test. It's just your answer choices will be graphs, and you'll have to be able to see which graph should it be. Does that make sense?
Yeah.
But for us practicing, we're going to draw it. Okay, so we want a 0 at 1, 0. Okay, so it's going to cross there. There's a hole at x is -1. Now, I don't know the y value of the hole, so I can't sketch that quite yet, right?
Yeah.
Now, I know the limit as, this is end behavior right here. As x approaches negative and positive infinity, you see that's end behavior. These two, what must be happening here? It's the limit as x approaches 3 from the left and the right, going to infinity. That means there's a vertical asymptote where? At 3. So at 3, we have a vertical asymptote. My lines are not the straightest, but you get the idea. Okay, so we've got a vertical asymptote. And as we approach it from the left, it's going down, right? So something like that. And as we approach it from the right, it's going up, right? Now the end behavior, we said, as we go left, it's going toward 5. And as we go right, it's going toward 5. What does this mean? We're approaching a specific number. That means there's a horizontal asymptote at 5. So that means this must come down like that. Bloop. And this one must come through here, right? It's got to go through that 0. This comes up through here. And I'm going to try and draw that a little better. That's pretty sloppy, y'all. I know, but still. So that means we got a curve here. And we've got a curve here somehow, right? Going this way. And I need to add in the hole, though. When x was -1, it's going to be around here. So there's going to be an open circle like here. When x is -1, wherever it happened to, this is just a sketch. It's not going to be perfect, but we get that those would be the asymptotes and that's where the curves would be.
So when we take the test, we're going to have the limit.
So you might be given information and which graph represents that,
Okay.
and you have to be able to pick which graph represents that, which graph shows that information. We good? Okay, but that's the end of that page. So I'm going to stop that video there, and I'll do the last page in a separate video because I did all the pages of the review as separate videos.